Hello, I'm Paul Licamelli, and this video is third in a sequence of 4 demonstrating experimental spectral editing in Audacity. As I mentioned in part 2, I have defined a few new effects, and I have bound them to keystrokes, which of course you can do with keyboard preferences. This, by the way, is the new interface for keyboard preferences in version 2.0.6. I can simply type a key and find the associated effect. You see a few new effects that I have associated with number pad keys 1, 2, and 3. One detail about the selection mechanism that I did not mention in a previous video is this. If I drag all the way to the bottom of the track, snapping happens. You notice the black line in the middle disappears, and you notice some of the new controls now display dashes. The selection is now in a state where only a high frequency is defined, but no low frequency. One of the effects I've defined can vary its behavior depending upon whether the top or the bottom or both are defined, and thus serve as 3 tools in one bound to one keystroke. So, a high-pass filter, or with a different selection, with only bottom defined, a low-pass filter, or defining both top and bottom, a notch filter. If I select some of the filtered portion and go to this dialog, Plot Spectrum, and notice I'm using the logarithmic horizontal axis. Notice the vertical scale drops all the way to -90. You see the effect the notch filter had on the flat spectrum of white noise. Reselecting over here and replotting, you see what a low pass does, a constant slope of 6 decibels per octave, and likewise high pass. Now I have undone those effects and I have zoomed out the vertical scale to maximum. I will demonstrate another multi-tool. This one performs shelf equalization. It requires a gain parameter, which may be positive. Here I'll use -10. And thus a low shelf filter, and likewise a high shelf, and the same for middle ranges. And now I'll just hit Ctrl-R instead of the hotkey, and it simply reuses the same gain parameter again without prompting me for it. And let's see what these did to the spectrum. The middle range filter, you see, has an effect something like pulling down several slides of a graphic equalizer together by the same amount. You'll see the vertical scale only drops by 10 decibels now. There are also transitional areas where there is a slope of about 6 decibels per octave. You may need to select a wide range of frequencies with this effect, or else the middle may not go all the way down as far as the gain parameter that you entered. And reselecting elsewhere and replotting, you see the effect of a high shelf, and likewise a low shelf. Lastly, there is the parametric equalizer, which we have seen previously. Let me enter the same gain of -10, and the effect on the spectrum has a much narrower bottom than the shelf equalization did. Thus, you see, I have 7 convenient basic effects using just 3 accelerator keystrokes. Here is the complete source code for one of those effects. I did not write it in C++, I wrote it instead in Nyquist Lisp. And what's that? Well, Audacity includes a complete interpreter for a version of the Lisp programming language, and it makes available to that language a number of functions that handle the basic mathematics of digital signal processing. It then becomes a comparatively simple matter to put together those pieces into a useful effect. Nyquist programming makes extension of Audacity's effects capabilities an end-user activity. An advanced one, yes, but still an end-user activity that does not require recompilation of Audacity's binaries. The resulting effects can be shared, and they often are, at the Audacity forum. Nyquist includes an interactive prompt in the Effects menu, which we see here. You can type some commands in directly, such as this. I will hit debug instead of OK to get the result of this print. And you see nil indicating that the bottom frequency is undefined, and the top frequency value, which agrees with what you can read on the vertical scale. My extension thus makes the new selection information available to Nyquist Lisp in the two global variables f0 and f1. Once they are available to Lisp, many things become possible. The effect that I wrote includes some extra code to check whether or not the top and bottom frequencies are defined, invoke the appropriate effect in that case, and also do a little bit of cross-fading of the processed signal with the original, about 10 milliseconds at the start and the end. That's useful to avoid introducing discontinuities because of phase shifts in the passband. Once you have saved this Lisp code in a file, and placed that file in the appropriate folder, and restarted Audacity, then a new effect appears in this menu. And then it's also easy to assign an accelerator key to that effect using keyboard preferences, as we've seen previously. There are more sophisticated spectral editing programs that do such things as interpolation of Fourier transform data across a gap. I have not attempted anything that complicated, but it could be done as a future extension, and it could even be done entirely in Lisp. This completes Part 3 of this demonstration. Let's proceed to Part 4 and see this feature in action, cleaning up a real example.